Good morning, everybody, and welcome to the Jupyter Interactive Widget Ecosystem tutorial. My name's Matt Craig. I teach physics and astronomy in Northwest Minnesota, so I hopped on a plane a couple days ago. It was nice and 70, got off the plane, walked to the bus stop, and almost died. In winter, you folks from Texas are welcome to come up and visit me in Minnesota, and you can have the exact opposite experience. We're fortunate to have a big group of people here presenting, and so we're going to introduce ourselves as we go through the presentation. But tutorial presenters, if you could stand up and wave, please, so everybody knows who you are. And Jason, you're tutorial helper, so just wave. Before I jump into the content, I want to check, does anybody need help getting this open? Or give me a thumbs up if you're ready to run. Okay, if you're not quite awake yet, just don't make eye contact and you're good. So the way things are organized here is that, except for this index, the notebooks that we're doing are in the file browser on the left and are arranged in order. So telling you all of this so that when I get lost, you can help me get found. First, questions. Please ask questions. It's really helpful for us to have questions. One of the interesting things about the couple of years that we're online is that online we got many, many, many more questions during the tutorial than we did when we were in person. I'm sure that if those had been in person, people would have had all those questions, but it feels a little bit harder maybe to ask in person. But it actually helps us if you ask questions. It helps us adjust the timing. We know whether to speed up, slow down. So please do ask questions. If you prefer to ask them electronically, we are watching the Slack channel as we go on, and feel free to post in Slack and we'll try to answer there. So a little bit about Jupyter Lab. Let me start with, how many of you use Jupyter Lab all the time? Okay, so I'm assuming by contrast the rest of you don't. So I'm going to take a couple of minutes and go through a bit of the mechanics. So there's file browser on the left, and double click on a file to open it. One thing that may be handy as we're going through this so you can see things a little bit better, you can either click on the file folder to collapse that, or if you push either Control B on a PC or Command B on a Mac, that will also show and hide the file browser. To run code in a notebook, click in the cell where the code is, hold down the Shift key, push Enter, and that runs the code. So go ahead and run to the point where you've got a slider showing. Everybody have a slider? Okay. So one other handy trick that's going to be useful later in the tutorial is that we can create a new view for any output and move it wherever we want. So on the slider, how do you have right-click set up? If you right-click, or whatever you have it set up to be on your Mac, then select Create New View for Output, and you'll get a new view of the slider. So it really is the same slider, and you can drag that output view wherever you would like. So if there's going to be a couple times where we're working on a widget, we make the widget, then several cells later, we're making some changes to the widget, and it'll be handy to drag a view of that widget off to the side so that you can see what's going on as you're working. So a little bit about the widgets. The widgets are controls that are displayed in the browser. Under the hood, the widget itself is written in JavaScript, but the focus today is going to be on the Python interface to that JavaScript. So everything you're going to see today is going to be all in Python. A widget, and this first widget we've called slider, has a value. So I'm going to add a cell here. Print out the value. It's 8.2. So all of the things I'm talking about now we're going to come back to in more detail. But you can do operations on that slider and observe changes in the slider. So as the slider is changed, this function handle change will get called, and it'll calculate the square of the value of the slider. And I have no idea what the square of 8.2 is. That looks plausible. Let's try that. Right, so notice it is updating the value of square as I move the slider. Sometimes all you really want to do is just figure out what's going on with the function. You don't want to have to write a lot of widgets code. You've got some function you're interested in, and you just want to get a sense of how that function behaves. And there's an interact function which creates widgets for you without you having to type any widgets code. So here we've defined a function that squares a variable. If you call interact with that function as its first argument, and you give it, you've got some options here that we'll get into in a little bit, but you give it some information about what the argument is, and it will generate the widget for you. And as you drag the slider, it's calling the function, and the function's updating. My favorite example of this, I taught a cosmology course several years ago, and I was trying to explain that the observational data was consistent with a bunch of different possible parameters for the universe, and they didn't really seem to be getting that. So I said, okay, there's 8 people in the room. All of you take this widget, and I want you to adjust the parameters, density, and Hubble constant for the universe until you match the data. And then I had them share their results, and they were all over the place. And then I could go back and say, so that's what that error ellipse means, that the values could be any of those, and you'd be consistent with the data. Some of the exercises in the tutorial will have solutions, and loading those is fairly straightforward. There's just one gotcha. So you uncomment the load, you execute that cell. Wow. And then disappointment ensues. So we decided to that is a much easier solution than what I was going to do. Thank you. Okay, so running that loads the code for the solution, but it doesn't run the code for the solution. So run it again, and you get the solution. So you've got links here to a bunch of other widget libraries. We'll be talking about some of these in the tutorial. Some of them we won't. For many of them, we have notebooks in the tutorial that we're not planning to talk through, but are there so that you can look through them at your leisure. And most of us are here most of the week, and maybe over the weekend too. And so if you are trying this out and you have questions, nothing makes us happier than when somebody walks up and says, so I was trying your tutorial, and it's like, wait, stop, just let me enjoy that. So as a little bit more framing, I wanted to show an example of a Cova Dashboard. This link actually does not work right now, and I did not write this dashboard. But when COVID started, one of the faculty in my department was I decided to work on a computer science degree and was taking some I don't know what the course was, taking some course. So for his homework, he made a Cova dashboard that showed a running count of cases. You could choose a couple of different locations to graph data for, a bunch of different information you could choose to plot, whether you want a logarithmic scale, et cetera, a map which you could hover over to see infection rates in a particular part of the country, and all of this is written in Python. The code is, as far as I know, is still here, but the dashboard itself is not running when I checked a little while ago. So there's quite a bit you can do with just Python. So it's, by leaving out the JavaScript, we're not omitting anything essential that you need to write some interesting apps with widgets. Any questions before we move to the next section? Okay, so up at the top here, there's a breadcrumb thing so you can get back to the index. And with that, I will hand it off to our next presenter, Eunice. Looks like I left my mask somewhere. Oh, it's in my pocket.
Cool, thank you. Well, good to see everyone. Good morning. I'm So my name is Yunus. There's a little blurb about me somewhere. If you're interested in knowing more about me, I'm happy to talk more about myself, but I feel like that's maybe not the topic here, so I'll just get right into it. So if you navigate back to, I guess I already have the right folder open. So if you go inside of the first folder in here, I'm going to go through the first notebook at the top here. And so I'm going to be getting into more details for what Matt was talking about in terms of the mostly interact in this notebook. So, and like Matt said, it's way more interesting for everyone if you ask questions, so feel free to interrupt. I know it's early for me too, but feel free to just raise a hand and start talking, because I don't especially like talking, so whether someone else did the talking. But I'm here. So, right, so we're going to start with some imports at the top here, and it'd be great if you ran through this with me and let me know if you run into any issues. This is mostly going to be repeating a lot of stuff that Matt already said, so I'm going to go over this pretty quickly. But we're basically just auto-generating UI controls for function arguments using interact. And the way we do that is we basically just create a function and then call interact, pass the function, and then we can pass several things like Matt hinted at. Here we're just going to be passing a value, an integer, and what this does is that it creates some defaults for the slider, and you can slide the slider around, and you see that the value at the bottom here gets updated. So yeah, another thing that you can do is instead of passing an integer, you can pass a boolean, and what this does is that it creates a checkbox. And so here the value for x is a boolean, but it translates into an integer because our function is multiplying things by 3. So there's that. And then if you pass in a string, interact will understand that that you want a checkbox. And it does the same thing. It multiplies your string by 3, which in Python translates into this thing here. So, and instead of creating things a little, this is a little clunky to write a function, write interact, you can also just use a decorator. And this does the same thing where it creates in this case, it creates a checkbox and it creates a float slider. And we're going to get into how the float slider bounds are defined right after this section. So yeah, any questions? Does that make sense? Cool. I also kind of want to know, first of all, I should have started with that, and I meant to, but I forgot. Does anyone use interact all the time? A little bit? No? Okay. Great. Well, this is hopefully useful. Great. So another thing that you might want to do is you might have a function where you want to explore one of the arguments, but not the other one, right? And so you can, in this context, you have a function where you're returning a tuple of the values that you pass in, which isn't super useful, but it illustrates the example pretty well. So instead of having 2 sliders like you'd expect here, if I didn't have the fixed keyword here, you only have 1. And this slider controls the first value of the tuple, which is expected. So yeah, we're going to move to widget applications now. So this is something that I sort of talked about a little bit at this point, but basically what happens for in interact is that you pass in a value and interact interprets that value and understands that what you want is an int slider when you pass it an integer. And what happens really is that the integer gets transformed into an int slider widget object with some default parameters. But you don't have to worry about that if you don't want to. The nice thing if you well, it's good to understand that, because for one thing, you can pass in additional optional arguments in here. And in this case, you control the minimum of the slider, the maximum of the slider, and the step. These are the default values, so this actually creates the same widget that we've seen above. But if you wanted, a positive integer, then you'd be able to do that by controlling this. And there's an easier way to do that, and we're gonna talk about that in a second. But you don't actually ever really need to declare the widget explicitly this way. So yeah, I'm going to pause again. Any questions? Cool. All right, so this is just a little table that summarizes like what arguments do what. So if you pass a Boolean, it creates a checkbox. A string creates a text box, etc., etc. And there's like a special case for drop down that we're gonna get into in a second. So yeah. Great, so this is what I was talking about a second ago when I said that you didn't actually ever need to create like that widget object. You could just pass in a tuple, and this will understand that what you're talking about when you're passing in like these two numbers is that you're talking about the minimum and the maximum of the widget. And this is still like using that function that we had defined above that multiplies things by 3. So if you multiply 0 by 3, you get 0. If you multiply 4 by 3, you get 12. So it seems like it's working. And a float slider is, if you notice here, these are actually integers, but because the third argument that we're passing is a step, it knows that what we want is actually a float widget. And we can move that around, and the precision that we get here is 0.01. You'll notice that sometimes it goes a little crazy. That's just like precision stuff, so we're not going to get into that now. But I think what it's attempting to say, 0.26 here. That's close enough. So here we're going to stop for a few minutes, and I'll just give you time to like go over this exercise. You can be creative with it, or you can just do the obvious here. But basically, we are giving you a function that reverses a string, and do something with interact that interacts with that string and turns it into something cool. So I'll leave you to do that for like let's say 2 minutes, maybe, and pick up again. Or you just feel like chatting, that's fine too.
So there was this mention of packages that expand the Ipycongos system, and does interact with those guys, like is there a way to interact with parameters?
Yeah, we're gonna talk a little bit about that later, but we're not. It won't be interact directly, but we'll be like observing a value change and then plugging that into a BQ plot or something. So we're gonna talk about like how widgets can interact a little bit. Yeah, thanks for the question. Cool. I see a lot of post-its. Are we good to go? Anyone have any questions? Is anyone running into any issues? That's a no. Great. So I'm just going to load the solution here. And so what we did here, which maybe isn't like the most creative thing to do, but you could like maybe reverse a string by like jumping 2 at a time and like rotating around the string, but whatever. Here we're just like, plugging in something. Hello world. And it reverses it in real time. It's wonderful. Great. So moving on. Still no questions, right? Awesome. That's what I like to hear. Maybe. Okay, so this is talking about default arguments again. So if you wanted to have a slider that starts at a specific value, the way to do that is that this is one way to do it. You can use the decorator like we said above, and then you pass a default argument inside of the function, and this starts the slider at 5.5. And this is talking about dropdowns. You can create a dropdown by passing in a list. The list can contain strings or whatever you'd like. And you create a dropdown with those items. And then you can also pass in tuples. In this case, what this does is it creates a dropdown with values here that link to the other values. So the function is actually going to be using the second part of the tuple to compute this value. And that's that magic. And here we're going to get into something that's a little more involved, but we're going to talk about the old way to plot things, and then we're going to go over something that Ian put together for like a better way to create plots. And we're going to play with this for a little bit. So I'll let you run this. And so this, oh, actually I'm going to have to restart this. Never mind. What? Is that what you're going to say? Yeah. Thank you. Oh, no, that's also not going to... Well, actually, this would work. Okay, fine. That'll work. Well, actually, it would work because I'm not running it again. But so... Oh, no, that's still not going to work. Okay, so just restart the kernel and run just that's all. I'm just going to re-import it. Okay, so this is the old way of creating a plot. So I'll just go through the code really quickly. So you create a plot, you clear it, which doesn't do anything because the plot is right now. Well, the first time the function runs, it doesn't do anything because the plot is empty. It creates a grid, and then it creates this like sort of like range object, but it's not really a range object of like points that are spread between -10 and 10. And you're picking 1,000 points between that interval, and then you're plotting that. You're plotting this function with these parameters that are being passed in here, and then you're specifying that you want your y-axis to be limited between -5 and 5, and then you just show the plot. And so this is also passing in, the ranges for M and for B, and this seems to be working fine. But as the text in here gets into, we'll go over the reasons why this is suboptimal. The first thing is that it's actually recreating the plot every time you move the sliders around. And you can't really tell right now because there might be some optimization happening in the background. I'm not actually entirely sure how that works. But for the fully interactive plot, you'll see that things are a lot more elegant. The other thing about this is that there's no zooming or panning, so it's just a pretty standard plot that doesn't offer a lot of features. And the screen currently doesn't jump, but it will in a second. So a better solution is to use I just jumped. Is to use Metplot Ipympl. Feel free to correct me, Ian, if I'm not pronouncing that right. And what this looks like, so I was talking about panning and like moving around, so you can select the controls here, and you can move around the plot, and you can also just save the plot to something if you'd like. The other nice thing about this is that we are actually only changing the data that is plotted. So if you look at here, what's happening is that you have this line object that's the plot, and you're changing the set of data that is being plotted, as opposed to changing the whole plot. So the fun thing to do here is that if we go back here, and I'm not sure this is entirely a good way to do it, but you'll notice that now that if I change these parameters, what actually happened in the background here is that you create a new plot every time, and you can see this because the figure number keeps increasing, and there's it's jittery because again you're recreating the plot every time. So great. I'll pause again. Any questions for that? Yep. Did you like run all cells or? And the plot just doesn't show. I think Itai can help you. Yeah. get you time. You can take a look. Is anyone else running into the same issue? No. Okay. Is anyone? Is everyone able to? It sounds like. Is anyone not able to create the plot? It's another person that's not. Okay. 2 people. So. The libraries are getting locked up. Oh, okay. Did you go through the installation instructions in the tutorial README? Okay. Hey, Jason. Thank you, Jason. Anyone else? Okay. Cool. Well, I'll keep going for now, but let me know if you're if the 2 of you are running. Oh, it's usually when I wake up. You'd definitely be woken up at this point. Great. So I'm gonna keep going for now, but we'll come back to this if we need to. Actually, we're going to have an exercise in a minute, so I'll give you plenty of time so that people that are having issues can catch up. So this is going to talk about Mpl Interactions, and we can automate here interactions using Matplotlib. And so this is basically just like a more straightforward way of doing what we just did above, with a lot fewer characters. So this is creating 2 things: the figure and the data, basically, and then creating a grid. We're setting the limits again, and then this is the same function that we've been using so far. And you can do what we did above with just this command, and it creates a very similar plot. So we are going to give you some time to go over this exercise and making a plot. And yeah, we'll maybe give you 5 minutes for that. So it's 8:31 right now. If I see a lot of post-its, I'll cut it short, but let's go to 8:36. Yeah, if y'all are done with the exercise, the post-it would be great, and we can keep moving. If you need more time, it's also fine. You just say so. Anyone needs more time? No? Okay, great. Cool. So this is just giving you more information. If you'd like to know more about Interact and Interactive, you can look at the example in the Ipywidgets source repo. And we will be going to so this also there's this other notebook that you can go through. Yep. So if you create a float slider, it'll be floats by default. I see. Cool. Any other questions? Yep.
So this every interaction goes back to the kernel and then goes back to the other.
Yeah.
So we assume there's no lag, but basically it's possible to get rid of the lag there is sort of the communication with the kernel.
That's right. I mean, that's yeah. I think that's probably most of it. Yep. Ah, yes, yes. Yeah, well, Jupyter. We'll be talking about Jupyter Lite later, which does that. So, cool. Thank you for that question. That was interesting. Anyone else? Okay, cool. So we are going to go back up 1 folder and then open the basics and open this simple widget introduction. So this is just going over like the concept of a widget, what they can be used for, yeah. So it's maybe like at this point we've interacted with widgets. The sliders were widgets. What they really are, and this is sort of getting into the question that you're asking about the kernel. They have their own display. It allows them to be displayed using Python display framework. And actually, this is not the part that I was thinking. Oh, is this the text I was thinking about? Yes. What are widgets? Widgets are eventful Python objects that have a representation in the browser. So there's a back and forth. There's the fact that they have a kernel component and they have a front end component. And yeah, so as we've seen, we can use them for interactive GUIs and all sorts of things. And so we're also just going to be going through a few things here. So the widget, the insider display, by default, if you just run this, what happens here is that we're calling the display method, and it just like shows the widget object. You can also just call that explicitly, and so in this case you're importing display and displaying the widget, and you can do that several times. So if you do that, you actually it's the same widget object that you're controlling. So when you change the value of one, you change the value of the other one as well. So this is a little diagram that explains like how that works. So basically, the widgets are represented in the back end by a single object, which is why when you modify one of them, both of them change. Each time a widget is displayed, a new representation of the same object is created in the front end. And these representations are called views, but they're actually pointing to the same widget in the back end. Any question? No? Great. So we're gonna go over some properties of a widget. As we've seen, this is our friendly widget. It has a value of 28 right now. You'll notice that if I change this, this doesn't change, but I can run it again, and it'll update. You can also just change the value manually. We'll get into an exercise a little later, but if this is like more than default, this is not going to change anything. Same thing if it's like minus 100. Our widget is not going to be able to handle that, but we'll get into like how to circumvent those limitations. Another property of a widget is the keys. This is it's just it's basically just a dictionary that has like a bunch of keys, and these are all the properties that you can access that belong to the widget object. Great. I think that's it in terms of. Well, I guess this is also a property of a widget. You can set the text manually by you passing in like some optional arguments like disabled. In this case, you're not able to change the text box, which is maybe again like not the most useful, but if you also, I don't know if you're familiar with this, but apparently you mentioned earlier that maybe not too many people use Jupyter Lab, but you can I think it's like Shift tab, and you can look at the signature of this, and in this case it doesn't tell you a lot because it just says arguments, but sometimes it's useful to like know what arguments you can pass to, in this case the text method. Great, so that's it for the properties. Any question on that? Cool. Great, so here we're gonna go over linking two similar widgets. So if like we saw earlier, you can you can display a widget twice and they're linked, but they're only linked because it's the same object. So this is like a way to like explicitly link widgets are of different kind. And so in this case, we're creating a slider and we're creating a like an input value. And so like if we change the value of this one, we also change the value of this one. Similarly to earlier, like if we go above 10, this doesn't work anymore. But again, we'll go into how to not run into this issue. And in order to unlink the widgets, you can just run this. I think this is because Yeah, sorry about that. There's so if when you link an object, it will return a link object, and then you can break that by unlinking it later. So right now they're linked, and I think if you do this, they're not linked anymore. So so yeah, just sorry, I forgot to add this to this box, but great. Any questions? No? Okay, cool. So this is going over observe, which is another way to control the way a widget is the value of a widget is set by basically observing like a property. So in this case, we're creating a slider and we're creating an HTML widget, and then our function is taking in change and picking up that new value and taking the square. And this is also something that Matt went over quickly in the intro, but basically we're just passing the function to observe, and then we're telling observe what property we're observing for. So in this case, we're observing for the value. And so the value here is going to be updated with the change from the widget. So again, like this isn't like the most momentous thing because you feel like you've seen this before, and we sort of did. Like this is what something like that we ran earlier. I just added this for comparison, but this looks a lot like the same thing, and it kind of is. But in this case, the bottom part here is it's an HTML widget, which is a thing of its own, and the two are linked but by using observe, which is different from the linking that we did above. So yeah, does that make sense? Cool. Any questions? This is the end of this notebook, so we're going to be moving to the next one. No questions. Great. Okay. So if you if you navigate one folder above and then go to widget list, we're going to go over this first notebook first. Cool. So I'm just giving you a minute to open it, but great. So in this, we're going to go over the communication framework between the front end and the back end, and well, I mean, not explicitly, but we're going to go over how that works and a set of fundamentals, user interface elements like buttons and checkboxes. So the main thing that I think this shows you like the power of widgets. I'm going to let you explore this for the exercise, but there are lots of things that that are at your fingertips when it comes to using widgets. And this is kind of a fun way to just use some of them and see what you can do with widgets. So let's pick up again and do maybe 13. Is that 13 minutes? Is that too long? Matt? So y'all can get started with the exercises and just exploring what you can do with widgets. And I think we'll do let's do 8 minutes instead, and yeah, pick up at whatever that is, 55, I guess. Okay. So well, I hope you enjoyed playing with all the widgets. We're gonna move to the last section in this main category, the widget overview, and this will give you a sense of some of the stuff that you can do to like connect to an output, and then or connect to a widget that displays a bunch of sub widgets, and then connect to it and place it in different spots on your browser. So I'm gonna go through the code here. So what you're creating here is that you're creating an output widget that has a cyan blue color, and then after the widget is created, you can still like add things to it. So in this case, what we're doing is that with this output widget, we're going through range and printing hello world 10 times. And I guess I should, where's that? So Matt said earlier is that you should be able to, where's that? Create new view for output. Yay, thank you. And I'm going to put that on the side here. And so I can add some more stuff, and you see that this gets created. Yeah, so you can also direct rich output to the same area. In this case, we're displaying a Jupyter interactive widget tutorial from a previous year. And you can display complex MIME types, such as nested widgets in an output widget. So this is a slider. And you can append outputs to the widget directly with the convenience methods: append, standout, append, standerror, and append display data. This is a different widget at this point because I guess this one's getting overloaded. But let me just do that. Output to the side. We're not currently able to display widgets. What happens when you try to do that is that instead it refreshes the widget, but it displays the widget underneath it. There's an issue that has a lot of history, but it seems like it's not. I don't know if Jason can maybe talk about that. It's not really a question. There's this issue that's been it was created in 2017, but it looks like it's been closed. But I think the issue is still there. Okay, it's issue 1811, in case you want to look at it. And then you can clear the output. In this case, we're clearing it with wait just for fun. So you can, if you just clear the output, obviously the output just clears. If you pass wait, what it does is that it waits for the next time you try and add something to the output widget, and then it'll clear it before adding that something. In this case, I'm just appending something, which still appends it. It does not clear the widget. But if you were to like add an int slider with this this syntax, this would clear the widget before adding the int slider. And then you can also use this as a decorator. In this case, if you run this and you're scared, don't be. This is intentional. So what you're doing here is that you're capturing all the output from this function, you're printing stuff, and you're raising an exception, and they're both being passed into the output widget, and it looks beautiful. So yeah, then you could just clear the output, and that's that. Any questions? Is that a question? Oh, yay! Cool. No questions. Great. So so here we are. I don't remember what this part is about, but okay. So here we're just like interacting with widgets in a way that's like a little more, I guess, it's better on the eye. It's like a little nicer to look at, I guess. But basically, you're creating a horizontal box with these two widgets, and inside of the first one, you're going to have a vertical box with int sliders, and then it just like shows things. It's like pretty to look at, I guess. Yeah. The sidecar is basically like the output widget, but it's on the side. It's, I guess, a faster, easier way to do what I was doing earlier, like clicking on the widget and placing on the right-hand side. And so we're creating here a sidecar with the name example that we can close, and you could just recreate it. If you create another one, it'll have the same name, and that's okay. At this point, you have like this one is not going to be used anymore. Your sidecar is the second widget that you've created. So notice how they're sold different objects, but you don't have access to the first sidecar anymore. And you can do the same thing with the output widget and use it as a decorator, and then capture the output from a function. And so in this case, if you run the function, it captures the print, which says greeting from the function. And you can do the same thing with sliders. Yay. And you can also clear the output. And here we'll go into an exercise, and after that we'll have a break. So I think the break is meant to be 10 minutes, and this exercise should probably take you about 5. So we can probably reconvene at like, let's say 9:20 or 9:15. Let's do 9:15. So feel free to take a break, go for a walk after you've done the exercise, and we'll reconvene here at 9:15. And it'll be someone else talking, so if you're tired of hearing my voice.
All right, everybody, we're going to go, oh boy, sorry. Get started on the next section, which is section 3, Widgets Events. So if you go back to the notebooks, and you go to the second number 3 that's here, and then open the first notebook in that. That's what you want to do. Is this big enough? Can everyone see? Should I make it bigger? In the back, mostly. All right. So in this sorry, I'm Ian. I use widgets daily as a grad student. My advisors is always like, change this plot, make it like that. So they were very useful for that. And in this section, we're going to talk a little bit more deeply about how to work with callbacks and how to set up sort of events manually, which is a bunch of stuff that Interact does for you automagically. And this is a little bit more of the lower level, how to use it, how to interact with it, how to debug some of it. So let's get started. Let's hide some of that. So there's a library called Traitlets, which is where widgets inherit all of their sort of observe, link, follow along behavior from. And so you can, there's some links here where you can read about that in more depth, but we're going to go over sort of the basic how-to of how to use it. And so this is sort of mostly information for reference, and we're going to go over this sort of via example. So we've seen a few examples of this, which is in the kernel. By in the kernel, we mean in Python. And so registering callbacks to trait changes. Traitlets creates these things called traits on widgets, which are like value is a trait on a slider. And those are the things that we can follow. So in this example, we've seen this before. We make a widget, we make a display, and we'll talk more about, Matt will talk more about this layout a little bit later. And there's a key difference. This is actually the last example from the basics section. And there's one big difference, which is that in that section, we had names equals value here. And for the moment, we're just going to comment that out, because I think a really common thing that you can run into when you're working with widgets is you set up some callback, and it doesn't work, and you don't know why, and you have to figure out why. And so if we get rid of this names equals value and you run this, it looks fine. But if we move this around, the square no longer works. And so the big question is why? Clearly there's some error going on, but where the heck did it go? And this is sort of demonstrating the importance of that names argument. And so to figure out what was going wrong, there's actually 2 approaches we can do. One is the Jupyter Lab log console, which for me sometimes shows up down here and sometimes does not. And so you can also see it if you go to View, Show Log Console. And when you read that, you can see that we're getting a unsupported operand type ** for pow dict and in, which is confusing because sliders should only have a number is not a dictionary, a number should be an integer. So in order to investigate a little bit more deeply what's going on, a nice thing to do is to use the output widgets like we did before. So in the next cell down, I've copied a lot of the same text from before, so we can mostly ignore that part, and look at the new stuff here, which is this output line. So this is a way I really like to debug interact, observe kind of things. I make an output widget, I display it right away so I don't forget to do that. Then I capture the function, and then I just print out change, and it will also capture the errors like we saw earlier. So if you run this, and then we move our slider around, sometimes it works, sometimes it doesn't. But we can also look at what was printed out here. So we can see that in addition to what we expect, value, and then there's a number here, which is great. Sometimes we're also getting changes from property lock, which is not something that we want to track and use to multiply or take the power of. And so the key difference here is that when you do observe without any extra arguments, the names argument becomes traitlets all. So it listens to every single possible trait or anything that updates and has this sort of callback system on a widget. And so what you can do now that we've sort of figured out what the core error is that we're listening to too many things, we can come back, and this is again the same code, just replicated, and add back this names equals value, because value is the part of the slider that we want to track. We want to know what its value is. And now we can see that we just get the change argument of this, okay, the value has changed, so everything works because we can get change.new, and it's not a dictionary, it's just a number, which is awesome. An important thing to note is that it's not just when you're moving the mouse around here, it's also when you change the value by code. So anytime the value changes, so if we do equals 3 here, you can look at the last one. Last new is 80.6. Slider value, the new value is 0.3. And then so a final thing, we actually touched on this earlier with the .keys argument, which I have to admit I didn't know existed. I've always done .traits. You can see all of the things that are observable in this way or that might show up in a observe, or also all the valid arguments to names can be found by any widgets.traits function. And it tells you not only what the name is, but also what sort of thing it is. So is it a list? Is it a Boolean? Is it a float? And you could play around with that print function and change the name and see what all these things look like. Are there any questions about any of that? I truly do not know. That might be in the traitless documentation. Yeah. It's like it's an object level like instance, but they get defined as class variables, which always was confusing to me as well. But each instance will have its own thing. So those are objects themselves, is my understanding. Yeah. Good question. Anyone else? All right. And this is something we sort of touched on earlier, which is that one of the other things Traitlets provides is this sort of validation of values. Sometimes values will be coerced to be what Traitlets what the widget says it should be, and sometimes it'll throw an error if you set it to the wrong thing. So in this cell, if we have a float slider and we set its value to a float, that works. That makes a lot of sense. If we set an int slider's value to a float and then we print it out, we'll see what happens after we run this cell. And finally, if we set an int slider's value to a string, we'll also see what happens. So the float slider was fine. The int slider got squashed into being an int. And then if we tried to set it to a string, we get a long error message that at the end tells you what's going wrong, which is sort of a nice thing. And if you run into this error, it's probably what it means, and you have some sort of, you're giving your object the wrong type. All right. So to sort of come back to using observe and arguments to observe along with outputs, got a quick exercise, hopefully quick. I don't know, maybe it'll take a long time, then we'll learn something. To make a text area widget, which we've created here, and then use an output widget and observe to print out the reverse of whatever's in the text widget, which is an exercise we did earlier with Interact, and this is sort of how you would build it up from scratch. And similarly, put your post-it up when you're done. I see not everybody has finished. Some of you have. If you're having trouble, first of all, be friendly. There's people next to you with little post-it notes up, so ask them what they're doing. But also, does anyone have any questions or is stuck on anything on this? Does anyone really want more time before we talk about the solution? Cool. All right, let's talk about the solution. So we load the solution here. The trick is to do capture the output of the function that prints out the reverse of an argument. And so remember, change is a dictionary. And so we call the new argument of the dictionary, which will give us the new value of whatever thing we're tracking. And then we use this little Python indexing slicing trick to reverse it. And so for observe, we just do reverse and names equals value, because value of the text area is the thing that we want to track. And the way you can remember that is that it's almost always value that you want to track and almost never anything else. And then you could, of course, look at the traits that it has. And so if you run that, hopefully this works. It prints that out a bunch of times. And so if you wanted to, you could also clear the output in between each one, but I didn't do that in the solution, and I think this is also fine. Any questions about that solution now that we've sort of looked at it? Mm-hmm. Yeah. So that's actually something we're going to talk about sort of at the bottom of this notebook. If you want a sneak preview, the continuous updates argument is what we're going to use for that. But we will get into that. Although we should use this example there, and maybe in the future we will. So it's a really great question. Thank you. Anyone else? All right. So another thing we talked about earlier is using link. And so there's a little bit of overlap between observe and link, it would seem. If we're linking two widgets together, why would we use observe, or why wouldn't we use link? What's the difference? And I think that they have overlapping but also slightly different use cases. So observe is really nice if you want to have a side effect like printing something out, or modifying a Metplot libplot, or saving a file, connecting to something that's not necessarily a widget. But link, if you just have two values of a widget and you want to two different widgets and you want to link their values together somehow, link is a really awesome and easy way to do that. And it doesn't just directly link them. You can also give a transform argument, which is an arbitrary Python function that takes an input in and transforms it to something else that will then become the value of the next thing. So here, for example, we have two sliders, and we can call widgets.link. And again, if we hit Shift-Tab inside of this, it will tell you everything there is to know about using this function. So it takes tuples of the widget and the trait you want to follow, and then the other widget and the other trait that you want to link. So if you do this, you run this, when I move one slider, the other one also moves, which is pretty sweet. So these are two different sliders, not two views of the same slider. And notably, you are not limited in linking one trait name with the same trait name. You can mix any two things that have compatible types. So sort of a lot of code here, but I think let's look at what it does first, then we can talk about it. I have a main slider which can just move around, and I have another slider which controls the minimum of the first slider. So if I increase the minimum, you can see that now the minimum of this slider is 8, If I decrease it to -10, suddenly the main slider has a different minima. And so you could do this with all of the different properties that these two sliders have. You could do it with a range slider. You could use a range slider to control the max and min of the other slider if you wanted to. But again, the critical line is this one, this widgets.link line. And here we have min, and here we have value. So any questions about that? Cool. So then we have another exercise, which is to use widgets.link with the transform argument to link the two temperature degrees Celsius and degrees Fahrenheit. So right now, if you change one of these, the other one doesn't change. And 32 Fahrenheit is not the same as 5C. We should have changed the numbers to be more work with the Austin temperatures. But what can you do? It's more like 40, I guess. So in the next cell, you can actually just do it in the next cell. You don't even need to put it in the same one. This should be a one-line solution. You can use these two functions up here for the transform argument, and then widgets.link like we were doing above. And so let's take 3 minutes or so to do that. And again, if you're stuck, I encourage you to be friendly with the person next to you. They might know something you don't, and you might know something they don't. All right. Again, reminder about the post-its if you have done it. Seeing some post-its, and it is the sort of 3 to 4 minutes that I claimed originally. So are there any sort of outstanding questions for people who are working on this? Errors you're running into? All right, cool. So let's look at the solution real quick. You can also load this yourself, so just delete that. Load this, and then you remember you gotta run it again. And so now if we change this, they both change, which is great. And hopefully the temperature will go down. So again, looking at this, we just have one widget. Oops. One widget and the trait that we want to follow, which is its value. A second widget, the trait we want to follow, which is its value. And then the transform is just a tuple of the two functions in the same order. So degree C, we do C to F. So that's corresponds to the first one. And degree F is the second one. So we have F to C as the second function. Does that not make sense to anybody? Totally reasonable if it doesn't. And please raise your hand. Right on. All right. So we're going to move on a little bit to, I wish that just rendered. Oh my goodness. Some more advanced widget linking. Link is not the only function. There's also D-link, which is a one-way link, so directional. And then there's things we're going to talk about a little bit, which are pretty nice. Jslink and Jsd-Link. So Jslink, remember we were talking about the widgets exist both in Python and in the browser. And there's sort of this layer of communication from browser to Python back to browser, which can take some time. And so Jslink, what it does is it links the widgets directly in the front end in the browser. Then it also gets synced back to Python, which is good. But for the display, it can actually be a little bit faster to do a Jslink, which we will look at. So this is an example mostly for reference. If you just run this, we have just create some sliders, and we have a D-link. And so if we change source, target will change. But if we change target, source doesn't change. And that's because this link is a one directional. Similarly, like other links, this can be broken, calling unlink. Now none of it connects. At any point I'm going too fast to give you a question, please just yell at me. I will be happily stop. And so then this is the JS link that I was just talking about. So it works exactly the same sort of syntactically to using link. You just add a JS in front. And now if I move these around, they are synchronized. And this happens first in the browser and then makes its way back to Python. And similarly, we can do the directional linking via JavaScript. So This is my understanding of the differences between linking in Python or linking using JavaScript. You can write a Python function to transform your values if you link in Python, but it is slower and also doesn't necessarily work. If there's no Python kernel, it's not going to work. And you can have widgets outside of the context of a Python kernel. They can be in a website. And so client linking is better sort of in that sense. And there's a lot more details on this in the widgets documentation. Like paragraphs of text go into great detail, which is awesome. And just as a quick example of that, to sort of drive this home, here we have 3 sliders, one which is the leader, and then 2 followers, which are either linked in Python, which is the client link, in Python, which is the one called Python link, or in JavaScript, which is the one called client link. And if you move these, you can see that the JavaScript link ones stay in absolute lockstep, whereas the Python one lags it by a little bit just because it has to go back and forth. Any questions about any of that? That's a little bit of a whirlwind through a variety of functions, but perfect. And then we're going to talk about continuous versus delayed updates. So this is what the person over here noted earlier, is that sometimes you want to have some control over when the sort of observe or the update fires. And so for sliders, it's normally continuous. Anytime it changes at all as you move it along, the value gets sent. But you can also make it not continuous. So you can make it so that every time a change happens at all, it sends an event, or you can make it so that it only happens sort of after you're done interacting with it. So this is an example, and I'd encourage you to play around with this to sort of get a sense of what delayed versus continuous updates, the difference between them. And then here's a quick summary of what widgets default to continuous update equals true or versus continuous update equals false. That's a typo. And then the final part of this section is this idea of special events. So things like buttons don't really have a value per se. Like if you just click a button, it gets clicked, and then it just is a button again. So for buttons, there's an on-click method where you can register a callback. You can see what that looks like here. So here's an example of using that on-click. And that's everything I had to say about widget events. Are there any questions about any of that? We can also talk about it in breaks later or anything. But yeah. Cool. Yeah. I don't know that there is. That sounds like if there's not, it would be a great thing to have. Is there, Jason? Do you know? There is a page in the documentation about throttling and debouncing that also has some more, but that was like maybe a little bit too in depth for today. All right, cool. So I think I am done, and Matt is next.
So we originally had a break in here because the battery delay was just if you wanted to stretch through a while while we're switching computers, but we'll
Skip our built-in 5-minute break here. All right, so if you go up one level to the notebooks, we are going to go into folder 4 about widget styling. If you could please start with the notebook that's numbered 0401, that would be great. The 00 notebook has some broken links in it at the moment that will get fixed later today, but I'd like to start us out in this notebook. So we're going to spend a little bit of time talking about style, which is something that a limited number of widgets have, and you can change a limited number of the styles. We'll spend most of our time talking about layout, which is how the widgets are arranged on the screen or within each other. I believe that in ipywidgets 8, there are more style attributes than in 7. But as an example of a style, I've created a button, and actually, let me check. So folks in the back, is this readable, or do you want it large? Okay. Right, so the some widgets have a style. That style, in this case, I've just set the button color. There are several choices for colors. Not all of them are good choices. As with, so the style attribute is itself a widget. And so just like you can look at keys for other widgets, you can look at keys for the style. So there's two things in the button style that I can change. I can change the button color, or I can change the font weight. The nice thing about styles is that the style is a widget. It's an object. You can share it between different buttons. So if I want to make all of my buttons this terrible yellow, I can do that. I'm going to change. Don't remember why I changed it to red, except I really don't like the yellow. Sliders also have a property. You can change the color of the handle. And if you click this link, there is a list of all of the style keys. That's for widget 7. We'll update that when widget 8 is released. Buttons and progress bars have a couple of custom styles for them. So I'm going to make a button. And there's a warning style, a info style, and a few others. One thing to note about the styles is that if you, well, let me back up half a step. So notice here I'm using button style, not just style. So apologies, the language here is confusing because there's a style for the button and there's a button style for the button. And you want to make sure you style your button with the button style, not with the style button. If you set the style to a particular color, that overrides button style. So if you find yourself spending an hour at the keyboard frustrated trying to figure out why you can't change the button underscore style, that's why. I would imagine that kind of thing could happen anyway. So there's a bunch of layout stuff that we could talk about, but in the interest of giving you a strong foundation for being able to put together lots of other interesting widgets that we're going to get to in a bit, we're only going to hit some of the highlights. Many of the layout properties here are derived from CSS. And so when I first started using widgets, one of the things I had to learn was if I wanted to learn about, to some extent, about the layout or a little bit about the styling, I had to Google for CSS, not for Python. And there's a number of CSS properties that can be set. We won't go through all of these, but they are listed here for completeness. In many of the properties, if there's a shortcut, so let me, yeah, so overflow is a good example. In CSS, there's often a shortcut name for a property, like overflow, or a couple of specific names, an overflow in the horizontal direction, overflow X, and an overflow Y. Whenever we can in ipywidgets, we just provide the shortcut property. Border is one exception that's changing in Widgets 8. So let's look at an example. So just like there are styles, there are layouts. So here I'm going to create a button, and I'm going to give it this layout. So it should take width-wise, it should be 50% of the display area. Height should be 80 pixels and should have a 2-pixel dotted blue border. As with the styles, you can reuse the layout. So if I want to make another button that's the same style, I can do that. And the nice thing is, if I decide later that the 50% is too big, I want it to be 30%, I'm using the same layout object for both of the widgets, so I just change the layout, and that updates all of the buttons. So quick exercise here, say a minute or so. I'd like you to make the buttons border solid and green, and make the width of the button 70 pixels. You're welcome to make the border 70 pixels if you want, but I think that would probably be pretty terrible. So there's a question from Slack channel about whether button style is influenced by the Jupyter Lab theme. Let's. Oh, so it is effective.
Oh, it is Michael. Never mind. I thought it was a question.
Yeah, so the text color changed on the button. It's black now, and it's white when I go back to dark mode. So actually, yellow might not look so bad in light mode. Okay, look just as bad. So let's see, we can do this in a couple pieces. So I can set the width to 70 pixels. So in the border, we have to give it the thickness and what style it is and the color, and I never remember what order those go in, so I'm going to copy, paste, and modify. So one thing coming in Widgets 8 is that you will be able to give different colors to different sides of the borders. You're going to have a little bit more flexibility here. So now I've made the button smaller and changed the border. So once you move beyond one widget, and there's not a whole lot interesting you can do with a single widget. Interact is maybe an exception to that, where you have several automatically generated. Well, even there, it's not a single widget; it's several widgets. Once you move beyond one widget, the question comes up: how do you combine them? And there's a couple of different approaches to take. So in website layout, you can use a flexbox layout, which is great for laying things out in one direction, whether that's vertically or horizontally. There's also a grid layout, which lets you lay things out in 2 dimensions. We're about to go through several different approaches to laying things out. My recommendation would be, rather than using the lowest level widgets, the box widget and the VBox and HBox, we've got some higher level layout widgets now. A grid layout widget, a 2x2 widget, an app layout widget. Try starting with those first, and if those do what you want, great. If not, you can dive into more detail or you have more control particularly with the Flexbox layout. And we do have, for both Flexbox and for grid, there's some very detailed guides about using each of those. So there's a bunch more there if you want to explore that further. So we've seen a couple examples of boxes already. I think we've seen VBox a few times. VBox and HBox do essentially what you would think they do. HBox lays out widgets horizontally, VBox lays them out vertically. So here I'm creating a layout. So I'm going to create a box. I'm creating an item or a layout for each of the individual items in the box. I'm creating a separate layout for the box itself. So the items, their width is auto. So as the size of the box changes, they'll expand to fill the box. And the box itself will have a solid border and take up 50%. It looks like I'm making a button. Oh, I'm making several buttons. Let's see, so if I change the width here, so box.layouts.width. The buttons expand to fill that because the width for the buttons is set to auto. So in the next example, I'm not doing a ton of layouts. So there's going to be a few different widgets. They're going to be arranged vertically. And the layout I'm setting is how I'm distributing any empty space in the widget. So it's going to distribute that empty or in the box. It's going to distribute that space evenly between the items in the box. But notice that without me having to do anything fancy, or deliberate, the size of the widgets looks nice in a column, and the location of the labels looks good too. So if you just straight up use a VBox, you're going to, and you don't change any of the default properties of the layout won't look bad. There are issues sometimes with the lengths of captions. That can be fixed, and we've got a notebook. One of the optional notebooks talks about that in more detail. So I want to switch now to some of the more high-level layouts, and we're going to take a look at a few of them. There's a 2x2 layout, which does what you might expect. It lays widgets out in 2x2 grid. An app layout and a grid spec layout. For all of these, it's going to be handy to have buttons which expand both vertically and horizontally. So the cell, you don't have to understand in detail what's happening in the cell, but if you want the overview, there's a function up here that makes buttons which have this particular layout. So they'll expand to fill the available space. And then I've made a bunch of buttons that we'll use in the later examples. So make sure to run the cell, but it's not going to do anything. So here's what you get with the 2x2 layout. Maybe it doesn't look very flexible at first because it looks like you have to have 4 widgets. If you leave one of the widgets out, then the empty space will be occupied by one of the other widgets. Now, in this case, the reason that this bottom right button fills the whole space is that the height was set to auto. You can leave an empty space if you want to, so there's a merge argument to prevent widgets from expanding. You can access the individual widgets, so the 2x2 grid widget has a bottom right, bottom left, top left, and I can change the button style of the bottom right widget like that. And I can fill in that hole if I want to by setting top right to a widget. There are a bunch of or some style properties you can change about the grid. So you can, one of them is grid gap, which affects the space between the widgets that make up that go into the grid. So let me pause and see if there are questions. My very first year teaching, my students described me as a hyperactive gerbil on caffeine, which was not wrong. So, and the more excited I get about the stuff, the faster I tend to talk. So if I Yes. That's a fine question. So one of the handy things to do, if you're not sure what the allowed values are, is just put in some value. And Traitlets, if there's a list of allowed values, it'll print out what the values are. So it looks like one of the allowed values is double quotes, or you could probably use the Python none as opposed to the string none. So let's try that. Yep. So in fact, you can't use Python none. It's got to be the double quotes. But like I said, my preferred way to figure out what the values are as opposed to trying to look them up in the documentation is just to put something. There we go. Put something in, it'll tell you the values that are allowed. So, other questions? Okay. So another example of this using a plotting library called bqplot. I'm skipping all of the bqplot details here. We do have a bqplot notebook you can take a look at, but to keep us running close to schedule, I'm going to skip over the details of setting up the bqplot figure. So I've got a min slider, a max slider. The min slider affects the minimum value or minimum of the plot scale. Notice that I change the minimum slider. The max slider is changing, or appears to be changing. What's happening there is that, let's see, let me set the max down to -0.3. The range of values on the maximum slider is being set by the minimum value slider. So if we look at the linking, the maximum, and wow, I seem to have gotten, it's interesting, I've gotten all of the tricky ones here. So the minimum slider's maximum value is used to set the value of the max slider. Right, so I'm going to crank the max up here to 9.9, and once I've done that, the range of values available to minimum has changed. Now minimum all the way up to 9.9. If I drop the minimum down some and then drop the max down, the highest the max slider can go, or the highest the min slider can go, is set by, or is constrained by the max. So once I get the max down to 5.7, we're done. This was actually about layout. So maybe sorry, I just got distracted by the slider. So here's the layout. So the top left is the minimum slider, bottom left is the max slider, the bottom right is the figure, but it expands to fill both the spots on the right side. There's an app layout, which is also very nice. So again, I'm creating a bunch of buttons here to use in this widget that will automatically scale vertically and horizontally. And in the app layout, by default, there's a header, and then 3 center panes, a left, center, and a right, and a footer. You can omit any of those. So here, the footer is none. You can leave out the right sidebar. And like the 2x2, if you leave something out, everything else expands to fill the space. And it's a little bit easier to see that in the case where you left out the right sidebar and the center expanded to fill. So take a moment and make an app layout with no sidebars. I'm going to give you like literally a minute on this. So the approach here is straightforward. If you just set the left sidebar to none, you should end up with no sidebars. There are several different ways that you can affect the layout. So I'm going to make this app and then make a new view for the output. Down there is fine. So the first way I set the pane widths here, so the panes referring to the three things in the center. The first one is a fixed width in pixels, and the 3 and 1 means of the remaining space, give 3/4 to the center and give 1/4 to the right. There's another way to say the same thing. The FR is short for like free space or something. You can adjust the heights also. So this made the header 200 pixels of the remaining space, divide it between the panes area and the footer, with the size of the panes being 3 times the size of the footer. So there's a couple different ways you can think about the 3 and 1, either as fractions, but remember the total is 4, or as a ratio of the sizes. You can change, so app.left sidebar is a button, and buttons have descriptions, so we can change that. And the sizing options that I've been changing after I've created the widget can also be done when you create the widget by providing arguments to app layout. Questions? Okay, can I get a quick thumbs up, thumbs down? Do you want to do this exercise? 1, 2, 3, show me thumbs up or thumbs down. 1, 2, 3. If you're not awake, you don't have to do anything, that's okay. So I'm seeing mostly thumbs up, let's do the exercise. Gives me a chance to get a drink. Yeah, that might give you some motivation. Oh, have I had it on the whole time? Oh. So when you're done with the exercise, go ahead and put the post-it on your laptop so I know. And if you're running into issues or have questions, feel free to raise your hand and one of us can come over and help you or ask in Slack. So the question was whether you can nest the app layouts. You should be able to, because each of them is a widget. So let's give it a try actually. So app was a app widget, so I'll just put that in to the center. Yes. Guess this is an illustration of the difference between can and should, but right, the new Mandelbrot layout. Right, but we'll want you to quick click through each of the Mandelbrot widgets, and when you're done with that, we've got this great Xeno widget. So I'm going to load my solution for the app layout. So a couple things here, and this relates to the question that was asked about whether you can nest these layouts. To include the figure from above, I'm not reproducing the code from above. I'm just reusing the widget we created before. So that looks terrible. So the problem, if I remember right, is that I've got my min and max the same way. So let's change that. Oh, I bet its size got modified when it got squished down into there or something. Oh. That's unfortunate. And so if you rebuild the BQ plot figure, it works. Okay, thanks. So another layout is, I should pause. Other questions or comments? Thank you. Okay. So there's a grid spec layout, and this is like the grid spec layout in Matplotlib if you use that. And so the idea is that you create a grid of a certain size. Here I'm making a 4x3 grid, and then grid behaves like sort of like an NumPy array. You set each of the grid elements to a widget, and you get the grid out. So a couple nice things about this. If you have a button that you would like to have take up several grid entries, you don't have to use a bunch of loops to do that. You can just slice. And so when we run this, button 1 was, let's see, rows, right. The rows up to, but not including the last row, and column 1 through the end. Button 2 was all of the rows, but only the first column, and then 3 and 4 are set to specific grid entries. If you access one of the specific grid elements, you can change its properties. So in particular, this one spans a bunch of entries, but the way to get at it is just to grab one of the cells that's included in that range. You can change the buttons. You can reslice. In the next example here, we're going to have a grid of, this is a random set of bar charts and scatter charts, I think. But illustrating the idea that you can, if you use either bqplot or if you use ipympl, which is the widget interface to Matplotlib, then your Matplotlib graphs are widgets, and you can embed them into grids also, or include them in your layouts. And finally, there's a grid box. So what did I do here? So the children of this box are constructed here. So in this case, I've made 7 buttons, and the layout is a little bit interesting. So width means what you'd expect. It's going to take up 50% of the available space. The grid template for the column tells you what size each of the columns should be, and therefore implicitly how many columns there are. The grid template for the rows is laying out what you want each of the rows to be. You're not actually, so you look at this, you might think, okay, the biggest I can do is 9 buttons because there's 3 columns and there's 3 rows. In fact, you can do as many buttons as you want. I just put in 29. What this does is the column template really does specify how many columns you have. You can have as many rows as you want. The row template uses the template for as many rows as you give it. So I gave it for 3 rows, and then beyond that, it's using some default value. So if I were to add, say, a 200 picks here, then the first 4 rows are laid out according to this template, and the rest according to the default. I'm going to jump over to our outline and see where we are at. So we started at 8:30, so that's 10:04. Okay, so we're okay. I think I just accidentally did the exercise. I did part of the exercise. So take a couple minutes, look at this, play around with the grid box layout a little bit. This is one where when I first learned about this, I had to do some reading and experiment a fair bit to started to get comfortable with exactly how the template columns and rows works. And this is one case where I'll say, please don't ask me a question about this, ask Google. Or maybe Jason, or Itai or Mariana or or Ian, but most of what I know about this particular thing is right there on the page already. So go ahead and put a Post-it on your computer when you're ready to move on. So the exercises are primarily addressing how you handle rows that go beyond what you specified with the template. There's an argument you can give to set the size of extra rows. So this isn't the way you really lay it out, but shows that this is doing what we wanted. And I think that you can give multiple values like we did for the template so that the pattern that we chose repeats over and over again. One last example of a grid-based layout is that you can do the layout in words. Um, so here's an example of that. I made 4 buttons. I'm going to make a grid box, and the way that the way that that's laid out is with this grid template areas. So the header is going to take 4 columns. Main will take the left 2. The dot means there's going to be a open spot, and then a sidebar and a footer across the bottom. And so again, what's nice about this is you don't have to spend a bunch of time, and I'm not saying this in a derogatory way, you don't have to spend a bunch of time reading about CSS and HTML and figuring out how to do all of these details yourself. Over the last few years, the base Ipywidgets library has really progressed in terms of giving you some high-level container objects to work with. Okay, I'm just going to show you one thing from notebook, the next notebook, which is 0403. There's some interesting stuff in here to read through, but I want to make sure that we get a break in a minute. And so I'd like you to hop down to a widget for exploring layout options. And a heads up about this widget will work in Ipywidgets 7. It needs some changes to work in Ipywidgets 8. And run the cell that says from layout preview, import layout, and so on. So what's nice about this widget is it lets you put things into a box. I'm going to change the number of things in the box here to 10. And I'm going to shrink down the size of this a bit so we can. So I understand that you're not going to be able to read this from the back. If it's any consolation, I can barely read it from here. So actually, if I hold my head at just the right angle, the progressives are lined up right. So what's nice about this, right, is you can change a bunch of properties. So if you want to find out what would it look like if you gave your box a 30-pixel border, you can do that. This also exposes some of the nice properties of Flexbox. So just by changing a property, I can affect whether things are laid out in rows or columns, or rather, I'll leave it at that. You can decide what happens with overflow. So let me add a few more buttons here. And let me not wrap. And because I've got overflow set to scroll, I can scroll to see the extra buttons. If I wanted to hide them, I can do that. All this is great. Just want to make you aware that there's this tool for playing around with some of the layout stuff. You can experiment with what the various size parameters mean. And best of all, this is all a Python object. And so if you click on the Python code tab, it'll show you the code to do the layout that you settled on. So I think this is maybe particularly helpful if you need to do something and the containers that are provided in the package don't quite do what you want to do. This hopefully saves you some trial and error, or at least makes trial and error faster. So I think we'll wrap up the styling section here. There are a few more optional notebooks in here that go through some additional topics about widget-specific styling and widget labels. And in the, if you go back up to the notebooks, there's a folder for reference guides. And in there's a pretty long guide to the Flexbox layout model and the Gridbox layout model. I guess I should be clear. This layout widget was not written by me or any of the presenters. It was written by an enthusiastic widgets user a few years ago. So if you want more detail about layout and styling, it's there. Otherwise, let's take our break for 10 minutes. So we'll come back at 10:45. JWST released one image yesterday and another 4 images today. So and I'm an astronomer, so you're a captive audience. and my job is to teach, so Widgets, midgets. Oh, I should have read this in with the image widget. So this is a picture of a group of galaxies called Stephan's Quintet. It's 4 interacting galaxies and one that just happens to be in the same field of view. This image is a Hubble Space Telescope image, and this is the JWST image. So there's a couple of differences to point out here. One is that you don't see the spiral arm structures as much in the web image. So you do see that here in the Hubble image. When we switch to the JWST image, it's using infrared light, and what you're seeing here is the dusty regions where there's lots of star formation. And so you get a different read on what's going on inside of galaxies. The other thing is if we zoom in on this, right, you see a bunch of dots in there that are something. In web, those dots are galaxies. And you can yeah, I know, I can't believe this. So the background of every web image that's released today probably has new physics or new astronomy in it. No, so honestly, I don't know. I think that the ones that they're posting are roughly 4K by 4K. It might not be. I mean, the detectors, 4K by 4K is pretty big for CCD. You might have several of them in a camera, though, to make a bigger field. Oh, okay, so these are mosaics. Ah. William works at... So I'm not seeing any technical help yet, so. Okay, sure. So we're going to try switching.
No, I still need. I think it might be a refresh rate.
Okay.
If not, I might just use your
I mean,
computer.
that's usually the thing that kills the display totally if it's wrong. Ah.
Now let's see. So I have both of them here, right?
Mm-hmm.
So it's the computer is detecting it. It's fine. What I think it might be the refresh rate. Let's see. It's called decimator.
Yeah, that's what we want. 'Cause that's what we're going through.
So the decimator is detected here, as you can see.
Mhm.
60 hertz refresh rate. Yeah,
You try that?
has been tried many times.
I can get you another adapter. That's all I can do for you.
I have a different adapter,
Alright.
so that's that it didn't work with that adapter either.
Alright.
So it works with other computers. So I suppose Matt, I think you will need to. If that's okay.
Yep. So you want the 7 environment first?
Yes, please.
And let me turn on Do Not Disturb. Is that a truck driving by?
Hmm?
Is that a truck driving by or something? I feel the floor drive by.
Oh no, I have no idea. I was.
Okay, you should be good now.
All right. Thank you. I mean, I'm gonna use this computer for this one, but I have another session after this. So if we can kind of resolve it during the break, that would be nice.
All I can provide you is another remote or another laptop. I don't know why it's not communicating in. It seems to be working with the others.
It is detected by the computer.
Right.
I don't know.
I can provide another remote, another adapter.
I tried it with the other one. There's one here. Okay, whatever. That's fair. Yes. We good to go? All right, everyone. Let's get started on the next session. So, a quick introduction. So my apologies for the technical issue here. Apparently, this adapter doesn't like Windows laptops. Seems to be a consensus amongst not just adapters but many individuals too. So I'm paying the price. My name is Itai. I work for Bloomberg, a core widget maintainer. And in this session, we will talk about what's some approaches for building more complex widget libraries. So you will have seen some of the building blocks like sliders, drop-down boxes, combo boxes, buttons, and sometimes you want to compose this into some sort of application, right? That you can then create a dashboard from, share with colleagues, or just deploy on the web somewhere. And feedback that we've gotten from previous years is that managing state when the application becomes more complex is kind of a tricky topic. So this notebook here aims to kind of give you a very gentle introduction as to potentially some of the approaches that could work. Bear in mind that there isn't just a single solution or like the best way for doing things. It really depends on your application and what you're trying to achieve. Hopefully it's a good starting point, at least to get you to think about how to go about composing your widgets into something that is a bit easier to work with and deploy. So the way this is structured is you're gonna see a lot of code here that you may have not seen before. So I'll briefly go through what each line of code means, but we'll have other sessions, especially in the next section where we talk about additional widget libraries, where we will really explore a lot of these packages in depth. So if there's something that is unclear specifically with some of the lines of code, like park that question, and then I can either come in the break, or it is likely we will cover it in the next session. So let's start. We're going to create a data frame with some sample, like fake stock prices. And in this cell here, we are importing everything that we need to import. We are using Ipy data grid, which we will cover in the next section, to kind of take our data frame, stocks df, and create a data grid widget from it. And in these lines here, oops, that's not what I wanted to do. Okay, I don't know how to highlight on this. Let's see. There you go. See, the keyboard always works. These lines here create a BQ plot. A BQ plot. So a BQ plot based on the grammar of graphics kind of takes what a visualization is supposed to look like and kind of breaks it down into some some principal components like the scales, the lines, any of the axes, and the figure object, and you can kind of compose them into a chart. So this is what these lines are doing here, and then we have a HTML widget that renders HTML. Okay. Still nothing that you can kind of see. We're then defining a callback, so using the observe pattern that you are now hopefully familiar with, and we are going to observe any changes in the selections in our data grid of stock prices, and whenever the selections change, we're going to execute that callback here that essentially updates the BQ plot with the new data. And this is just a way of laying out the widget. So you can see everything is kind of verbose, everything is in cells. A lot of the code is kind of using global variables, which is good, when you're prototyping. I'm just trying to close this bar here. Option B, Command B, or Control B. There you go. So the way this works is you will click on a given column, and then what will happen is the chart will update with all of the values from that column. This is the application. Not very useful, but hopefully illustrates what what a complex application could potentially look like. Just think about if you were to kind of add just more widgets to it, then you kind of have to add more callbacks, manage more state, right? And clearly have a lot of these, a lot of the definition of the widget that you're using kind of laid out in different cells. That's not always easy to work with. So let's try and kind of take a more structured approach and repackage this in a Python class. So the first thing we're going to do is actually just create a class for our BQplot chart, because as you can see, it has a lot of moving parts. You probably don't want to have all these variables kind of laying around. You want to have a single class that kind of encompasses all of that state in a single place, right? And then being able to interact, you probably don't want to change the attributes of that class directly. You probably want to have setters and getters, and that's what we're kind of doing here, right? So we have a get figure, which returns the figure, get line, which returns the line that is currently plotted, and set line that kind of takes the x and y coordinates, labels, and any colors if you want your lines to kind of change their color. So that's the class chart class, sorry. We're going to have the same thing just for the application. So the way this is structured here is you have the data. So it's going to take your data frame, not the data grid. It's going to take your data frame, a raw data frame with the data, and you can kind of specify the title. And then everything else is kind of done for you. So some of the properties here, the data grid is going to be essentially whatever the data that you're passed in. And there's a process function, a process data function here. It doesn't really do anything other than return a data grid with the created from the data frame object that you've passed. But the idea here is that if you do need to do some pre-processing before you kind of ingest that data, you would probably do it in this place. A chart, which is by composition, we're just creating an instance of the chart class that we have defined above. The application title, and then you can see that under the, at the end of this, we're kind of calling this run application method. And you can see that run application method, the run application method itself has a method to call a class method for the setting up the event handlers and then displaying the layout, right? That's kind of what this thing does at a high level. And of course, we have all of these callbacks that are currently single one. You could have multiple, also defined as like a class methods. So if you kind of take this, so all you had to do is just create an instance of my application with the data frame of the stocks and the title, and that thing is working exactly as the same as the application that you saw above. Now the nice thing about this is now these are all classes, so you can use them as modules effectively. And this is what we're going to do. The next, if I can open it, that one, the next notebook. So we're going to recreate the same data frame that you saw just now. And in here, if you look under my application, we have created essentially a Python module, right, with init. And in here, we kind of, all the things that we want exported from that module, there's only one, which is called my application. We export, and then the chart class that we created is kind of encapsulated in this file here, and the application logic is just a copy-paste, really. There isn't anything that has changed between the two, is in the application.py. And then you just import it, and it executes in exactly the same way. So think of this as like probably the next step once you're more comfortable with which and you actually want to create an application out of it and potentially deploy using Voila. We will look at some of the options for you to deploy and share with others later in the tutorial. But I guess that's it. Any questions? Comments? Complaints? Yes? So just so I understand the question, you're asking if there is a way to declare the widgets in a React fashion, or so you would probably need to create a custom widget from it. There is, I don't know if we're covering it in this tutorial, but there is, I can show you. There are a few cookie cutters that you can use that essentially generate a template for you, where you have the JavaScript code, and then you need to kind of take care of the bindings for Python. But the cookie cutter will kind of sort that out for you, and then yeah, you can create essentially a custom widget package from that. But just using raw JavaScript, I don't think there is a way, right? There is, you would need to go via the Jupyter communication protocol. Cool. Then I guess this is it from me. The next session, I believe, is. Sorry. Yes, please. So it's an excellent question. For Ipy data grid, you mean specifically the data grid like this widget here? So the general gist is that in the current implementation, the entire data set needs to be kind of synced between the backend and the front end. So if you have a really large data set, there isn't any like a data streaming model here. So you would need, at least initially, to sync it with the front end, and then the front end, you can make some optimizations where only, in the case of the grid, if you were to change something, then only the diff is kind of synced between the two. So you don't have to kind of transport the whole data back and forth. But for BQplot, the data does need to come from the back end, at least for the lines object, right? So yeah, it's probably not the best solution for very, very large data sets. As for the actual boundary, when it kind of stops being optimal, I'm not sure. Sure. Cool. Then I guess Mariana, over to you. I suppose you can if it's not a Windows laptop.
So hi everyone, my name is Mariana. I work at Anaconda. Before I worked at a company that was doing several different Jupyter things. So I worked a little bit in like building widgets and also kernels. So I'm gonna talk a little bit about the extended universe of like widgets, because everything we saw until now is really the default library. But then there are many different ways that you can expand on it. So today we're going to look at Ipycongos, Ipycytoscape, IpydataGrid, and Ipyogony. And there's an extra notebook on other libraries that you can have a look at. And there are also many other more libraries in the ecosystem that we're not covering here. So as Itai was saying, we have a few ways of getting started with building your own custom widget. So there are the widgets cookie cutters. There's the JavaScript one and the TypeScript one. And then this will just generate all of the boilerplate code you need to create your own widget. And there's also documentation on it and a Medium blog post that you can check it out. answering your question more or less. I don't know who made the question, but so further on, we're going to see a way of using Vue to create designs for your notebooks too. So starting with Ipycongos. Ipycongos is a widget that expands on the canvas tag from HTML, and it allows you to draw all kinds of things. So you can start with polygons and shapes. So you have to import canvas, and here we're importing other kinds of canvas that this library supports, and I'm going to show later what they do. So first we load a canvas, and then you can add a color for the background and the color for the stroke that the lines you're going to draw are going to have. Here the line width, and here we're filling the polygon, and this is the stroke polygon, the thing that's going to go around. So you can create like simple stuff like this with a few coordinates. You can also use Bezier curves to create round things. So yeah, in this case, we're just passing a bunch of coordinates and then so we create a line around it, and then we use the fill function to fill the line. That's the shape of the heart. You can also create lines with it. Here we're just setting a background for it, but it's not really necessary. And then we're generating some random lines, and use the stroke lines function, and then you get lines. So this so the point of this part of the session is more like show off like what are the kinds of things you want to do. So I'm not gonna get super much into details on what each one of these things are doing, but here we're drawing a recursive tree. So here we're drawing the leaves, and then here we draw the actual tree. We define the style for it, and we also connect it to a button to generate random trees. So this is a cool thing you can do with it. So as you saw before, like you can generate lines, you can generate everything, anything you want. So another thing you could generate is like your own very customized graph. So in this case, we're using this library called Branca, and then it's a lot of configuration around it, but you get anything you want. You can generate any kinds of graphs you want. These are some other kinds of canvas that Ipycanvas offers. So this is the rough canvas. It works in the same way, but it gives you a cute drawing style. This is a game of life implemented just as a showing off like what else you can do with the library. And yeah, this is also another thing just to show off the library. Here, Martin, which is the creator of this library, he made this notebook. He implemented a Perlin noise function, and then you can generate beautiful things using Ipycongos. Yeah. I don't know if anyone here used it. Should talk about. Yeah, but I never did geometric stuff. But yeah, that's.
It's a pretty direct version of the browser canvas API. So if it's anything that like basically just use that, here it should work.
Yeah. Thank you for the question. So any other questions? Okay. So let's move on to Ipycytoscape. So Ipycytoscape is a library that's based on the Cytoscape SOP. Actually, it's based on Cytoscape.js, which is an implementation of Cytoscape, which is a library used to render interactive graphs. So here, yeah, so there's a small walkthrough here. So Cytoscape support many different kinds of files to generate graphs. You can use JSON, you can use pandas, networkx, or Neo4j to feed your graph with data. We're gonna have a look into how to add layouts, how to add styling, and then with networkx, the different kinds of graphs you can create. And then by the end, we have a little bit, we're gonna talk a little bit how to connect this with the ipywidgets default library. So you import it. This is how you create a graph object. And this is how data from Cytoscape looks like. And you can import it directly just as you would use in Java or JavaScript, at least this is the JavaScript port, and to a JSON file. And then it just generates a graph for you. This is the default graph, and it's interactive, and we'll see many different things we can do with it. So there are many different layouts that you can use. This is the default. I think it's the color one. But you can have grid visualizations. You can have circular visualizations. You can also have breadth first. I forgot another word for that. Dagri visualizations, which obey a hierarchy. Yeah, there's also this random layout, which is gonna random your graph in like different positions in case you wanna show it in different ways. So yeah, any questions? Maybe I should stop more often. Sure. I wrote this widget. Thank you for the question. Yeah, so another way that you can load data into the graph is using pandas. So here I'm creating a small data frame, and it's a data frame about robots and universes. And each robot has a universe and a coolness level. So I just create this universe, and the way you load this inside Ipycytoscape is by so there are three arguments. First, the data frame. Second is how you want to group things, and the third argument is how which columns should go inside of each group. So here I group stuff by universe, and then I added the robot and coolness level columns to it. So you get something like this, which is not very informative, but we can do stuff with it. We can, for example, add edges between things. Yeah. So here, for example, I'm connecting C3PO to R2D2 because they're connected. I think this is a typo that I should fix. This shouldn't. This created something. Yeah, this is something I should fix. But yeah, so here I'm connecting C3PO to R2D2, for example, and I can also add some styling to my graph to make things more, visual, clear. So, for example, I can paint C3PO yellow and R2D2 blue. So now this shouldn't be here. But now C3PO is yellow and R2D2 is blue. And another thing I could do is adding tooltips to my graph to be able to actually see what is the data that's inside of it. And yeah. Okay. So NetworkX. So for those of you who don't know, NetworkX is, I think it's the most used graph library in the Python ecosystem. It's the most famous one. And then, so Ipycytoscape is completely like interchangeable with it. You can just create graphs from network X. So this is one way of creating a graph. You can create a complete graph, and then I'm passing 5 nodes. And then I can just pass the network X graph that I just created here to my Cytoscape object. And it's just going to generate it for me. And it's just a Cytoscape object. And then you can have stuff like direct and indirect edges for your graph. You can have, for example, this graph is only direct, but you can also have a mix of both. This is direct and indirect. This means like if it has edges that are that have what's the word for that? A direction or not. You can also create custom elements. So if you have, for example, a very specific node that you want to create, that you don't wanna use a JSON for it, you can also just create it, and then create a network graph, and add these nodes. Like so here, for example, I'm creating a custom node that has an ID and has classes, and then I'm passing the ID and the classes here, creating the objects, and then I just add these nodes to my network X graph. And as you would expect, just like as we had up here, you can just create an object, a Cytoscape object, and then pass the network X graph to it, and then it just works. The Neo4j integration I'm not going to show, because for those of you who know Neo4j, it requires a lot of setup around. So I just, but there's an example that can be found here. It would take too much time to go over it. So here, I wanted to show a little bit how to interact, how the widgets, the complex widgets could interact with like the default library. So here we're gonna have a look on how you can interact with JavaScript events. So here, I'm getting my old graph from up there, and then I'm gonna set a style to it. I'm gonna say that all of my edges that have the class highlighted are gonna be painted red. That's what's gonna happen. So this is the style that I'm setting into my graph, and then so this is a thing that every time you set a new style, the previous style is set off to like none. So this is an issue that's open on Ipycytoscape. It's a PR that's open, and it's ready, but it's complicated. I'm not sure if we're gonna merge it or not. So here I'm gonna create red edges, and I'm gonna create a button that has a callback that goes through every edge of my graph, and that's the class highlighted to it. Because as I set up here, every edge that has the class highlighted, it's going to be painted red. So I have my graph up here, and if I click the button, then all the edges are painted red. You can also, you can use any JavaScript event, in fact. So underneath here, I'm using a different event, that's the click event. So on click, I want to paint all of my nodes blue. So every time I have the blue class on the node, I'm adding this class here in this line. I'm gonna paint my node blue. So it's listening for the click event. So if I click here, it doesn't work. But if I click on my nodes, then they're painted blue. So this is the list of events you could use, all of them. And whoops. And this is an exercise. I'm not sure if you have time for it. We don't?
Well, we've got about 35.
All right, cool. So we don't have time for it, but it's just like a little exercise on like how you could do, how could you exercise this idea of like working with widgets. You want to talk about Ipy Data Grid? You can do it for that now. Do it here.
If you're having Ipy data grid installation issues for whatever reason, seems like Safari doesn't play nice with it, I'll come see you after this. Just going to briefly, because we are kind of pressed against time, just going to briefly kind of breeze through this. Ipy data grid is a library, as the name suggests, that is a data grid. The idea here is that you can take, if you do a lot of EDA and you want to kind of explore your data, but you want to have a more interactive way of essentially working with your data frames, Ipy data grid is a great tool for that. It essentially takes your data frames and it converts them. Here's an example data frame. You just pass it as is, and you can kind of see that it created a data frame out of this for you. Let me just create an output for that. What was the trick with it? Okay, figured it out this time. Just going to briefly go through. This is, okay, sorry, this is the one I need an output for. So yeah, you can, it has all sorts of parameters that you can kind of adjust, like you can see the height of the column header and the width of the row headers. These names might take a while getting used to, but hopefully they're intuitive once you do get used to them. You can change what this thing looks like, right? You can, if you don't want to have any kind of headers or no header visibility at all, you just want to look at the raw data, you can do that. Not that you would want to do that in many occasions. Ipy data grid supports, the idea is that each one of these cells that you see here is rendered using a renderer object. And we currently have, this one says we have 2, we actually have, by now we have 3. Text renderer, bar renderer, and hyperlink renderer if you want to kind of render any links. And all of the attributes of these renderers, like the color, the font, the text, the background color, all these things can be controlled using Vega expressions. We didn't invent Vega expressions at Bloomberg. It's just a part of Vega, the Vega grammar, open source project, but we kind of embrace it as a way to give you a constrained way of specifying conditional formatting based on the cell value. So this is a Vega expression expressed as a Python function, and that Python function takes one parameter. That parameter is cell, and cell, think of it as like a dictionary that has a list of attributes that you can access. They're listed right here. So the cell position, height, the cell value, X, Y, etc. So let me show you what this thing looks like. So we applied, some conditional formatting here and played around with different renderers. So you can see the grid now is showing bars, showing essentially different sizes of the text and different colors using color scales. And yeah, just gonna quickly go through these. You can also style the headers independently, as you can see here. And you can apply what we call transformations. So that can be any kind of filtering or sorting. You can do it programmatically, or you can do it from the UI right here. Right, you can do any kind of filtering like that. Conditional formatting based on another cell. So this is. So here we're essentially we have a signal. If the return is positive, we want to buy. If the return is negative, we want to sell. So kind of the signal column is conditionally formatted on the value of the return column. It supports nested hierarchies, right? So this is a nested hierarchy data frame, and it kind of just works, right? You can just kind of pass it in. We also added some conditional formatting because why not? And two-way selections. Right, I can kind of select something in the grid, so I can select like this range and then go down here, and that range is highlighted. That's just a range. Think of it as like an iterator, but I can also get the values if I want to. There's more selection stuff here, kind of repeats the same thing. And you can have an iterator if you don't want to have, if it's a large grid and you've selected a lot of values, but you don't want them kind of taking all your memory space, you can have an iterator that kind of yields the values as they're kind of needed instead of having them all in a list. You can change the selection mode, so you can have like a selection mode that is like row-based. So instead of clicking on a cell, you can have the same for columns. This will select essentially all the all the rows that are this one I selected before, but even row number indices. Yes, let me see if there's anything else in here. You can edit two ways, so I can kind of put this, change this to 1, and you can see that this changes. This will now reflect also back in the kernel, so you have this two-way data binding, which is awesome. It's really, really nice if you just want to change something. You don't want to have to go through a number of pandas operations. Yeah, you can set cell values programmatically, so not just from the UI. And this is an integration. This shows you how to kind of integrate with ipywidgets with a broader ecosystem. This example is actually the example that you saw in the building more complex libraries. So we don't have to go through it in detail. This is just an example of linking. So we have the slider. You can see the slider here controls the minimum property for a color scale that we have. And you can see that we're kind of playing around with the value. Basically, we're restricting the range of the color scale, and that in turn affects the rendering of the bars. And yeah, this is the stock DF example that you saw previously. Some nothing novel here. And that is IPy data grid. And I think Ipycongos, and that's it. After that, right? So back to you.
Yeah, maybe we should skip this because we're short in time. But this is just because we tried to show different things, and just that it's also possible to render 3D things. The Jupyter Notebook and Ipycongos is apart from the Paraview. I don't know how to say that. So you can render really cool things, and it's possible to do like some really cool interactions with ipywidgets. So yeah, so another thing I wanted to talk about this. So we're leaving kind of like the widgets side of things and going more to the what are the tools that you can use to leverage your widgets. What's the word when we were talking about this earlier? When you put it out there for people that are publishing, this kind of stuff. So one very good tool is Voila. Voila is used to create dashboards, and then someone was talking about using, I think, React, but Voila allows you to use Vue. So I'm not really a front-end developer, but so you can import ipyviewify, which is apart from Vue, to Python, and then you can program the interface of your notebook just like you're programming Vue. So you have tabs, tab items, layout, and so the cool thing about Voila is that you can also, in case you're also not a front-end developer, you could also use the stuff that Matt showed earlier. So this is just some code creating a dashboard, and then I'm going to show to you how to run Voila. So all you have to do is to use the word Voila and then pass a template if you're using any template. So in this case, we're using Vue. Here, if you want to enable NB extensions, and then the path to your notebook. And the cool thing about Voila is that it's not only a static dashboard. This is running a kernel on the back end. So everything here works just like a Jupyter Notebook. This is basically a Jupyter Notebook, but it looks whatever is the way that you want it to look. And another thing I wanted to cover is Jupyter Lite. So Oh, sure. Sorry. Hmm. Maybe, well, I think I'm running this in different. So what it's important. So this template that I'm using is actually a library that you have to download. So if you don't, with Conda or Mamba or Pip, so if you don't have this library installed in your environment, then it won't look the exact same because you need this library if you're using Vue. And there are different templates. Yeah, I don't know where is a good link to see the different templates that they have. Yeah, but this, for example, is a different one. So this is green, and it's completely different. So there are many different. So maybe that's a problem. I don't know, because for me, something else happens. But we can look it up later. Okay, sorry. Do we have any other questions? All right. So yeah, so I want to talk a little bit about JupyterLite. So JupyterLite, so this is a link to the web. It's just a website, and it runs a complete Jupyter environment. And the cool thing about JupyterLite is that it supports different languages. So you can use not only like Python notebooks, like we're used to, and do all the kinds of things that you'd expect it to happen, except some little things that are, because this technology is leveraged. I think I went too fast. Or, I don't know, this is just showing, yeah. Error handling. Yeah, it's leveraged by Pyodide, and Pyodide doesn't support a few things. We're going to talk about this a bit later. But yeah, so you can also have a JavaScript kernel running, or Lua, or P5.js, or SQLite, or Ren, which is yeah, it's a less known programming language. But yeah, so for example, this is a SQLite kernel, and you can create database using SQLite, and create tables and insert into them, and show them with the Jupyter's metadata. And it's also possible to use Vega to run, to create graphs and this kind of stuff. So the cool thing about JupyterLite is that it doesn't have a server. You don't have to do anything. There's no command line. There's no need to install packages locally. It's super fast to open, super fast to boot. And you can also create your own, and it's super fast. You just have to go to this repository and then do what this GIF is showing here, and fork it, creating your own repository. Yeah, so JupyterLite, it uses many different technologies that many people have been working for a while. So it connects to Jupyter using the Zeus protocol, and to leverage all of these and to have Python in the browser is using Pyodide, and of course all of the rest of the Jupyter ecosystem that runs inside of it. There are a few possibilities to have files and running inside your JupyterLite. So you can use the local storage or the IndexedDB server. And you can also create shareable links to share just some specific files with other people. So maybe I can show this fast, or here. So I can select this, and then okay, it didn't work, but it was working. I don't know. I don't understand why it didn't work. Yeah, maybe some bug. I don't know.
So there are no security implications because it's all running
Yeah, and this doesn't have any access to your personal file system or anything like that. Everything. That's why the file system thing is a bit complicated because it's hard to load things from your computer and stuff like this because everything is enclosed in the browser. So yeah, so another thing, this is new. I don't really know what's the state of this, but people added, Kevin added the possibility to collaborate. So you can open 2 instances of Jupyter Lite and just have 2 people working on the same file. And I don't really know the details on the state of this, but as far as I understand, it's working basically everything you would expect. Yeah, and some of the limitations. So for now, you can only use for lighter workloads because of the limitations by Pyodide. You can only use micropip, and that means that you can only have fully Python packages installed in your Jupyter Lite. You can only use Python packages that are fully Python or that are supported by Pyodide. There are a few. Yeah, and I think that's it for this part. And I think we're gonna have Jason talking about, or is it Itai? Sorry. No.
So the upload widget should open to a folder that's got text file and image lab. So it should be all ready
Nice.
to go.
Thank you.
And it's not right there.
This is great because I had an image of me, which is like what I use for my green card application. It's not what you want to see. So we're gonna ipywidgets 8 is in a release. Everything you've seen up to this point is ipywidgets 7.6 or 7.7. 7.7. ipywidgets 8 is coming very, very soon. It's in release candidate stage now. And it's a major version upgrade. So there are some breaking changes. We're going to go through some of the changes that impact users, mostly in try and kind of summarize them. This is by no means an exhaustive list, so I would still highly encourage you to kind of click on this link and look at the full changelog. If you're a widgets developer, there's also a lot of relevant information for you there. We're not going to cover any widget developer related breaking changes in this notebook. Okay, so I suppose this is the correct version. Yes, it is. So the latest documentation is available here. Just make sure you have ipywidgets 8 selected there. So first, right off the bat, Python 2, any Python 2 support, and Python versions less than or equal to 3.5, they're no longer supported. That is a big change, right? Especially if you are using Python 3, but some of the earlier Python 3 versions just will not be supported. So just something to bear in mind. There have been a number of additions to styling. So some of the ones that you can see here are supported for core widgets, and here is an example kind of taking all of these and generating an output widget with all of them. It's not, we're not really good with front end stuff, so I know it looks hideous, so forgive us. But that's that kind of illustrates some of these changes and them kind of working across different styles. So that's one thing. Borders, right? There's been a few requests asking to set the border colors independently for each one of the sides. Previously, you could just set the border, and the border will kind of be uniformly kind of set across all different sides of the button. But now you can kind of do them independently. If that was an important feature to you, it is now included in ipywidgets 8. There is an entirely new slider implementation based on an open source project called No UI Slider. So this is what it looks like, and some of the things that it supports is kind of dragging the range, right? So there are a few. There's a new behavior attribute that it supports. You can kind of read about it in the documentation, but essentially, just something to also to be mindful of. The file upload widget has been revamped. There's been a lot of changes here. Some of the most important ones concerning users are here. Whenever you are uploading something, the dot value will actually give you a bunch, right? It's called a bunch. I think that's the object, which essentially gives you metadata about the file that you uploaded, together with a memory view, which is a binary representation of it. So let's see if that kind of show you what this thing looks like. So hopefully this is just beautiful. So we're going to choose two files, right? 1, 2, open them, and so this is what it looks like. It looks like this dictionary representation. So the first file that we uploaded is hello world. As you can see, it's text or plain. That's the size, content, and then the last time it was modified. And you can see that the content is this memory view object, which Python supports. So let's read some of the information. So for the text, if you wanted to read a text file, this is what you would need to do. So codex, decode, file upload, we're looking at the first index, and the content again pointing to this memview object here. And there you go, look at that. Clearly a computer of an astronomer. And for an image, it's going to be that image, isn't it? Has to be. It's a fantastic image. Look at that. Is that space-time warp, what we're seeing here? Whatever that means. Okay. So this just a summary of the changes to how you interact with files that you've uploaded. That's different from the 7.x versions, right? So bear in mind. You have tooltips everywhere. I don't know why it shows the file upload widget again, but you can see a teeny tiny tooltip appearing here. This should work for any other widget. That was not the case before, so you can kind of now put a tooltip on any widget that you render. There's an error widget fallback. I don't have any failing. I suppose if we use Safari, it will fail, right? I could use ipydataGrid, and you can kind of see the trace, the stack trace on at least on the Python, but also on the JavaScript side, kind of rendering nicely rather than this error where it says cannot display widget model, which is not really informative. So this is something that you're going to get. It's a much nicer way of, or more graceful way of handling widget failures. There's a new stacked widget. So what this thing does is essentially allows you to display one of essentially the selected index here. So we have two widgets, button and in slider. So if I change this here to, there's no escape button here. So how do I do this? No idea how to do this. Okay, yeah, that one. So if I do stacked, selected index equals 1, then you can see the slider. So that's a new addition. There's a new datetime picker. So previously you would kind of only select the date, but then the time will be like 0000, just the beginning of that date. Now you can be a bit more granular with what you select. And yeah, that's it. Those are the main changes in 8.x. If you're a widget developer, please do read the documentation because there are breaking changes. You will need to, if you're maintaining any custom widget packages, you will want to support both 7.x and 8.x. You would need to make some changes to make that happen. Any questions?